I hope everyone's doing fine. Okay, so it's right the time now, 7:50. So I'm just gonna start. Oh, let me just try to pin myself first. Can I pin myself? Yes, I can pin myself. All right. So in today's session, I'm just gonna talk about all these 14 questions. And some of them are easy, some of them are hard, some of them might be involving some topics that we haven't covered before. Hello, Doris. Hello, Cynthia. Wow, that's basically everyone. I think we are just missing Rosary, Sophia, and who else? And Kevin. Kevin is in Hong Kong, so that's understandable. But basically, that's everyone. Wow. So let's take a look at the first question. So the first question might seem very fancy. So you might think about using, like the difference of two squares to solve it. If you know what the difference of two squares is, basically, if you're looking for the difference of two squares, what you can do is that you can try to do A adding B, multiplying A, take away B, right? So this can be factorized into this, but in this question, it is not necessary at all because the numbers are small enough and easy enough. We can just do a direct calculation. It's going to save even more time than if you're using any fancy skills. So that's just 42 over 2, adding 484, take away 400, which is equal to 21 adding 84. Which is equal to 105. All right, so the 21 comes from the fraction and the 84 comes from there. So that's the first question. Easy enough, I guess. Now, let's take a look at the second one. It says that Jeff ran for exercise. He ran for a week, and that's a total of 30 kilometers. The average distance of the last 4 days was 4 kilometers more than the average distance of the first 3 days. So basically, there are two average values for the last 4 days and for the first 3 days. And if we are given the average, we can definitely find the total by multiplying the average by the number of terms we have, right? So since the average of last 4 days was 4 kilometers more, well, let's say the average distance of the first 3 days, let's call it A3, all right? Let's call it A3. And then for the average distance of the last 4 days, let's call it A4, okay? So we know that A4 is going to be equal to A3 adding 4 kilometers, right? So now for the total distance of the first 3 days, it can be expressed as 3A3. For the total distance of the last 4 days, it can be expressed as 4 times A3 adding 4. And that's making a total of 30. So now we can solve for A3 easily. That's just a linear equation. So we have 7A3 adding 16 is 30. Which means 7A3 is 14 and A3 is going to be equal to 2. So if A3 is 2, in the first 3 days, Jeff is going to run 3A3, which is 3 times 2, that's equal to 6 kilometers. Yeah? So that's the answer for the second question. All right, let's see who's new to the class. Sophia. Hello, Sophia.
Hi, I just rolled my aunt's dog, so she's on my lap right now and shaking really badly.
Okay.
Hi.
Are you in the US right now?
Yes, it's 11:54.
Okay. So like at noon, basically. All right. Interesting. So the third question is still pretty easy. Alice wrote a 3-digit number. Bob found that it would become a perfect square after multiplied by 10. Cindy found that it was also a perfect square after adding by 9. So basically, what it means when it's a perfect square after multiplying 10. Let's say we have a 3-digit number A, B, C, all right? Multiplying 10 is just going to add a 0 behind it, right? But for any perfect square, will it just have 1 0 behind the number? Like at the very end of the number, will that just be 1 0? No, it can't be just 1 0, right? Because if you have a factor of 10, it means that it's going to have 2 factors of 10s at least. So it means that it's going to have 2 zeros at the very end if you want it to be a perfect square. And now for the first 2 numbers, it's going to be a 2-digit square number if the last 2 digits are zeros. Because you can imagine it's going to be some 10s multiplying some 10s. So that's going to be, AB is going to be equal to 16 or 25 or 36 or 49 or 64 or 81. And it is also a perfect square after adding by 9. So we just need to put a 9 at the very end of each of these numbers. And we can easily tell that the only square number is 169. So that's going to be the 3-digit number that Alice is writing down. Okay. Wow, that's basically everyone. Hello, Roger. That's really everyone then. I mean, there's the 9 of you. Wow. Except for Kevin, who's in Hong Kong. So it's too late for him. And question 4 is still easy. Because for question 4, it would be lovely if we can do, like a tree diagram for the 5 steps. So starting from point A, you take 5 steps such that you are reaching point C for the first time. Okay, and it's asking you how many roots are there to satisfy this condition. So basically, you can use a sort of like a, tree diagram. You start from A, and then after 1, 2, 3, 4, 5 moves, you're going to end at C, right? Ah, that's okay. All right, so there will be 2 zeros at the very end of it. There will definitely be 2 zeros at the very end of the 4-digit number after adding the 0. And then you just take the first 2, add a 9 to it, add a row of 9 to all these possible first 2 digits AB to see which one of them is a square number. That's it. All right. And then for question 4, we know that it starts at A, it ends at C. So we just need to take a look at what are the points that it can reach after A in each steps, right? So first of all, after A, it can move, After A, it can move to B or E, right? So we have B or E for the first move. And after B, we can't move on to C because we want the 5th step, we want the, wasn't number 3. Oh, is asking about the original number. Oh, yes, that's right. The original number should be 160. My bad. Yes, you're right, Jack. It should be 160 for this one. I've been making some silly mistakes there. All right, back to this question 4. So after B, we are not moving on to C anymore because we want it to be the first time after 5 steps only, right? So it can only move back to A. And after E, we have 2 options, A or D, right? And then moving on from A, of course, again, we can go to B or E. We can go to B or E. And once it reached D, it can't move any further to C. So it has to turn back to E, right? So E here. And then for the next step, well, if I have a B at the 3rd step, you might be able to see that it can only go back to A for the 4th step, which means that it can't possibly go to C from A, right? So it means that if it is at B now, then it won't work. What about if it is at E? If it is at E, it means that I can go to D or A, but then we know A is not working, right? So we're just taking the root through D and then to C. So you can see that finally there are 3 paths that satisfies this condition, which is after 5 steps, it reaches C. So there should be 3 different routes for that. Okay, 3 different routes for that. All right. Any questions so far? Okay. So if that's the case, let's take a look at question 5. So question 5 is not about anything else, but about understanding the question. So it says that a 4-digit number, A, B, C, D, is a number which none of the digits is 0. Okay, so we have no zeros in the 4 digits A, B, C, and D. Now it satisfies the condition that AB, the 2-digit number, is smaller than 20. So if it is smaller than 20 and it cannot start with a 0, what could it start with? Naturally, A is going to be a 1, right? So A is going to be a 1. And then let's take a look at BC. BC has to be smaller than 21. Well, can it be 20?
No.
No, because we can't have any zeros in that number, right? We can't have any zeros, so it can't be 20. If it can't be 20, again, it is going to go into the tens, right? So it means that B is going to be a 1 right there, okay? And finally, what determines the answer is actually CD. CD is smaller than 22, so of course it can be 21, but it can't be 20. And if it can't be 20, but can it be anything smaller than 20? Yes, of course. Of course it can. So it can be 19, 18, 17, 16, 15, 14, 13, 12, 11, but not 10, because 10 has got a 0 in it, right? And anything smaller than 10 will be 0 something. For example, 09, 08. So again, it's got a 0. So now we can see that that's the complete list of all the possible good numbers. So that's going to be 10 numbers altogether. So the answer is 10. All right. And that's for question 5. All good? And next. Well, if any of you have any questions, just, either type it in the chat or just voice yourself up, all right? Otherwise, I'm just going to take the assumption that you're all understanding it properly.
Wait, are we allowed to talk?
Yes, you can. You see? Now you're talking. I can hear you. Why would I not allow you to talk, right? But it's just that I am uploading this to YouTube later. So I will just try to, not showing your faces in my video. So I'll see what I can do. But if, if you're showing, then I'm just going to send it in the group chat such that, so as to, protect your privacy. That's definitely very much important for me. All right, now, so for this question, so this question is something that you would require a little bit of extra knowledge. I would say that this is a little bit out of syllabus. So basically, before we start this question, we need to know that, for example, if I have a cube, with 1 centimeter length, and I have a cube with 2 centimeters length, what is the volume relationship between them? You can see that it's going to be 8 times, right? It's going to be 8 times because the volume ratio is going to be, yes, Tom, that's right, 1 to 8, 1 to 8. The volume ratio is actually is not V ratio, is like ratio of the volume is equal to the ratio of length cubed. Does it make sense? Of course, that's given when the two shapes are similar. All right. It means that they have the same ratio of dimensions. You can think about it that way. So when a smaller shape is enlarged, then you can say that the two shapes are similar. So they have the same shape, but a different size. That's what it means by similar, all right? And for similar shapes, the ratio of volume is going to be equal to the ratio of length cubed. So after we know this, that's what we are basing on to solve this question. First of all, we know that for any cones or any pyramids, the volume is going to be equal to the base multiplying the height. So the base area, that's what I mean. The base area multiplying the height, okay? So we know nothing about this circle right there. We know nothing about it. We don't know how big it is. But we know that this is 90 millimeters. Let's call it 9 centimeters, all right? Why bother calling it 90 millimeters? And this is 3 centimeters. So essentially, we know that if I call the base area B, then the volume of the whole cone is going to be equal to 12B. Does it make sense? Or you can also say that the volume ratio between the top cone and the bottom cone is going to be 3 to 9, or actually that's just 1 to 3. Yeah. What do you mean by the area also have to be divided by 3? They share the same base. They share the same base for the top cone and the bottom cone, right? Base times height divided by 3. So you mean like the whole, I see. Yes, basically that's right. I need to divide it by 3 because I'm just considering about the ratio here. All right. So that's kind of like that is not proper. That is not proper. I should say, if they have the same base, the height ratio is equal to the volume ratio. Thank you for pointing that out, Jack. That is not the best way of saying that. Yes, for cones and pyramids, you need to multiply a third, but that's the other story. That's the other story because we are still not learning about that just yet. But yeah, I'm trying to talk about the volume ratio between the top cone and the bottom cone right there. And now it says that it takes him 84 seconds to eat the first half of the height of the cone, which means that actually it's somewhere up to there, right? Which means that this section is going to be equal to 3 centimeters and that section is 6 centimeters. Now you can see that the base has definitely shrunk if I'm just taking the cone halfway, right? So if you want to know how long it takes for him to eat the second half, you need to know the volume ratio between the top half and the second half. All right, so the top 6 centimeters and the bottom 6 centimeters. Now, it's hard for us to find it as a whole, but then we can try to imagine the bottom cone alone first. So you can see that the bottom cone has height 9 centimeters, where the second half has height 6 centimeters. Because for the cones, they are all having a circular base. And then you can see that the steepness on both sides of the bottom cone must remain consistent, right? So you can say that these two shapes, they are similar, which brings us back to the like very beginning deduction we have, which is like what is that? The volume ratio is equal to the length ratio cubed, right? So it means that they have a volume ratio of 729 to 216. All right. Of course, we can simplify that, which is actually just 27 to 8. Okay. So if it is 27 to 8, it means that the bottom cone or the second half of the cone is 8 parts, where this midsection is equal to 19 parts. And the top section is equal to, well, 27 divided by 3, that's 9. So the top section is 9 parts, which means that it takes 84 seconds for 28 parts. That's a combination of 9 and 19, which means that each part takes 3 seconds. Each part takes 3 seconds. And for the 8 parts down there, it's going to take 3 times, so let's say 84 divided by 28 times 8, which is 3 times 8, and that's going to be 24 seconds. All right. Hopefully that's also making sense to you. Okay, so let's take a look at the 7th question. So the 7th question would require you to know the principle of, like the number of factors from its prime factorization. So I think we have talked about that before, like the number of factors. So it says that it's divisible by 20 and 22, and it has exactly 2022 positive factors. So first of all, if it is divisible by 20 and 22, it's going to have, yes, that's right. Question 6 is just a ratio of volume. Exactly. So for 20, we know that's equal to 2 squared times 5, right? And for 22, we know it's equal to 2 times 11. So we can easily tell that there are 3 different factors for this positive integer. Yes, of course. So the volume ratio is 27 to 8. 27 to 8. For the bottom cone, like for the 9 centimeter cone and the 6 centimeter cone, it is 27 to 8. So if you take away the 8 from 27, what's remaining for the, like the, a little bit of, like the trapezium beheart is going to be 19 parts of volume. And the top one, because the top cone, the 3 centimeter top cone and the bottom cone has a ratio of 1 to 3. So it is going to be equal to 9 to 27, right? So if the 9 centimeter cone is 27 parts, the top one is 9 parts. So we have 9, 19, and 8. So that we can just use the use the relationship between that ratio and the time ratio to find the time. Okay, so yeah, that's basically it. Any other questions for this one? Okay, cool. If that's the case, we can just take a look at this problem right there. So first of all, we are splitting 20 and 22 up to see what are the possible or what are the compulsory factors for this positive integer. And it says that it has exactly 2022 positive factors. So that's a bit annoying. How can I count 2022 positive factors one by one, right? That is nearly impossible, which means that what we can do is to use the principle of numbers of factors the other way around. Basically, it means that, for example, if I have, say, 24, that's definitely equal to 2 to the power 3 multiplying 3, right? So we can have 4 choices for the factor of 2. We can take 0, we can take 2, we can take 4, we can take 8. That's 2 to the power 1, 2 to the power 2, 2 to the power 3, and 2 to the power 0. So we have 4 different options right there, yeah? And for the factor of 3, we can choose 0 or 3, which is 2 to the power 0 or 2 to the power, 3 to the power 0 or 3 to the power 1. So we have 2 options right there. So altogether, the number of factors should be 4 times 2. You still remember that? I think we have talked about it. So if you still remember this, you can see that this is just asking us to break 2022 up into factors. So 2022 is equal to 2 times 1011. And 1011 is divisible by 3, which is 337. And now 337, after a few tries, you can see that it's actually just going to be a prime number. Okay? Is unfortunately a prime number. So it means that the three powers of the factors has to be 1, 2, and 336. Because we know that the number of options for each factor is always going to be 1 more than the power, right? Because we can also take power 0, which is essentially just 1, right? So we can have the powers 1, 2, and 336 split among the 3 compulsory factors, 2, 5, and 11. Now we can see that 2 would need at least a power of 2, right? So we can say that starting with 2 to the power 2, we can have 2 to the power 2 times 5 to the power 1 times 11 to the power 336. That's the first one. The second one is 2 to the power 2 times 5 to the power 336 times 11 to the power 1. That's the second one. And then, of course, 2 can have more than a power of 2. So it can be 2 to the power of 336. And for the other 2 factors, of course, we are just arranging them such that we have 5 to the power 1 times 11 to the power 2. That's a 1, okay? And times 5 to the power 2 times 11 to the power 1. Okay, so altogether we have 4 lucky numbers. That's 4 of them, right? Are we all good? Okay, you can see that it's slightly getting a little bit harder and harder, but hopefully still manageable. Let's take a look at the next one. So the next one is requiring you to do a little bit of Pythagoras theorem, but then it is asking for too much. It is actually asking for too much. Again, there are some knowledge that is which a little bit out of syllabus, you know. So first of all, if it says that the 3 sides are touching the rectangle at exactly 1 common point, it means that these straight lines AB and this straight line BC, they are called the tangents of the circle or the semicircle, which means that it is perpendicular to the center O. Okay, That's something which I haven't taught you. That's something which you are not supposed to know, but that's true. Okay, so if you have any line that is just touching the edge of the circle at one point, then that point joining up with center O is going to be perpendicular to, well, I can't say it's perpendicular to O because O is a point. It is perpendicular to the line formed by the touching point joining O. All right. So it means that that is a right angle. It also means that that is also a right angle. And of course, ABCD is a rectangle, which means that ABC is also a right angle. And because this is a quadrilateral, so this is a right angle. All right. So you can see that BGOH is also a rectangle. And to be specific, it is actually a square because OH is going to be equal to OG, as all the radii of a circle has to be the same, right? You know that if you take the radius anywhere around the circle, it's always going to be the same. So OH will be equal to OG. Now we know that BGOH is a square, AH is 10, and GC is 4, and BG is 5. We want to find FD right there. So what can we do? Basically, you would still, you would just need to do another assisting line right there, such that this is 4, and OF being a radius is going to be 5. So according to Pythagoras theorem, this is going to be 3, which means that, well, since this is a square down the bottom, all the sides are 5. So it means that across the length of AB is going to be 15. And now I know O to this point is 3. It means that FC is going to be 2. Yeah, that's right, Tom. So FC is 2 and DF is going to be 13. All right, because the two sides of a rectangle must be the same. So that's why we can see that FD is equal to 13. So in this question, it is pretty hard because we need to do a little bit of construction right there by adding some assisting lines to know what's happening, all right? So first of all, we have used the property that the tangents are perpendicular to the line joining the touching point and the center of the circle. That's one of the things that we need to know. And then now having the square down the bottom, you still need to imagine how you can find FD, right? So that's the challenging bit of it. But now that all the lines are drawn, I believe you should be all right with it. It's just a little bit hard to think about. You know, actually, when the headquarters give us the papers, they don't have the answers. Well, like they don't have the solutions coming along. So all I have is an answer, and it's taking some time for me to get there as well, because I was thinking that you might not be required to know about the tangents, but yeah, I can't think of any other ways without using the tangents though. So if you know any better ways than this, you can just let me know, all right? Basically, like all these methods I am using in this lesson is actually just the methods that I am going to use myself, because I'm given nothing else but an answer. So I've been trying to think about what are the easiest ways to, you know, share these questions with you, but that's already the best I can do. Okay, so that's for this question. And for question 9 is all right. Question 9 is not too hard, to be fair. It is a little bit abstract, but then once you draw the diagram and you might see what's going on. So first of all, we have school A and school B, where Ivan is traveling, blah, blah, blah. So they are towards each other. They travel towards each other. And then they meet at a supermarket 100 meters from the midpoint. So let's say that's the midpoint, and the supermarket is going to be 100 meters away from that. It says that after 10 minutes, Ivan reached school B, where Ellen is still 360 meters away from school A. So it means that, of course, Ivan is traveling faster than Ellen, right? So it means that where they meet the first time should be on the right of the midpoint for 100 meters. And that's what it is. That's what it is right now. And then keep moving on there. Oh, probably that's not proportional. So like keep moving on. And then after 10 minutes, when Ivan is reaching school B, Ellen is still 360 meters away from school A. All right, so what information do we have for time here? The only information is 10 minutes, right? And what about the information for distance? Well, we can see that on the first line right here on the top, actually they have a distance difference of 100 meters, adding 100 meters, that is 200 meters, right? So it means that when they first meet, they have a distance difference of, yes, you can use the ratio of distance, exactly. When they first meet, they have a distance difference of 200 meters. And then after 10 minutes, the distance difference has grown to 360. Can you see that? So it means that actually in 10 minutes, the distance difference has grown for 160 meters, which means that for each minute, Ivan is traveling 16 more meters than Alan. Right? Does it make sense? Okay. Any questions right there? So you can say that Ivan is equal to Alan, adding 16 meters per minute. All right now. So when they are traveling towards each other, let's see how long it's taking. So basically, that's a difference of 200 meters, right? So if you use 200 divided by 16, you can see that it's equal to 12.5 minutes of walking time till they first meet. And after that, Ivan is traveling another 10 minutes to get to school B, which means that if I have A adding 16 times 10 is equal to A times 12.5, right? Because that section is A times 12.5, and for the 10 minutes, it's A adding 16 times 10. Do you see what I'm trying to do here? I'm just equating, let's say this is ln for A. I'm just trying to equate this section, the two traveling, you know, like the two people traveling the same distance in that section. So we know that 2.5A is equal to 320, no, not 320, 160. Now divided by 2.5, what is A? A is going to be, what is it? 4 times 16, 64. A is 64 meters per minute. So it means that let's bring it up here. I is equal to 80 meters per minute. So altogether, they would have traveled 144 meters per minute, and they have traveled 12.5 minutes. So the distance is equal to 80 adding 64 multiplying 12.5. And that's going to be 144 times 12.5, which is, I guess it's 1,800 meters. Am I right? 1,800, 12.5 divided by 8. Yeah, 1,800 meters. Okay, so that's going to be the answer to this question. Have I made myself clear? All good? Any questions? Well, if not, then why is A times That's because you see the blue line right there. That's Alan's speed, right? And after Alan has traveled for 12.5 minutes, it's the same as Ivan is traveling 10 minutes. We know that the first time they meet, it takes 12.5 minutes because we can see the difference between them is 16 meters per minute, right? The speed difference between them is 16 meters per minute. And if the total distance difference is 200 meters divided by the individual distance difference per minute, it's going to be the time. Yeah. So we take the total distance difference divided by the per minute distance difference, and we get the minutes. We get the time. Oh, why is the speed difference 16 meters per minute? Good question. Good question. Because you can see that that's 360. That's 200. And then it's right after 10 minutes. Yeah. So it means that in the 10 minutes, the distance difference has grown for 160 meters. Okay. That's 160 on top of 200. I have been skipping some steps there though. All good? All right, then let's take a look at the 10th question. So the 10th question is actually a counting problem. You need to know about the probability. You need to know about the probability, all right? So it says a black bag contains several cocoa candies, milk candies, and fruit candies, all right? And then there are 3 scenarios. The first one is 3 cocoa candies. The second one is 2 cocoa and 1 milk. The third one is 1 piece of each kind. And the teacher says that they have an equal chance of getting what they want. So it means that the probabilities are the same, right? And if the black bag is consistent, it means that for the 3 of them, the denominator for the number of cases is definitely the same, right? We know that the probability is for the numerator, it's the desired number of cases. For the denominator, it's the total number of cases, right? So the denominator has to be the same for all three of them. Now I just need to make the numerators the same, yeah? So let's say for coca candies, there are C coca candies, M milk candies, and F fruit candies, all right? And then now what we are doing is that we want to use these expressions to express the number of cases that you're picking these candies. So first of all, for 3 coca candies, the number of cases there will be is going to be C multiplying C take away 1, multiplying C take away 2. That's like the normal combination, right? Because after taking 1 away, then you have 1 less of the coca candies right there. So that's like, for example, if you have 6 coca candies altogether, then the number of cases you can pick the coca candies is going to be 6 times 5 times 4, right? But then, because the 3 of them can be in any sequence, yeah? They can be in any sequence. So you need to divide it by 3 factorial, which means that is C times C take away 1 times C take away 2 over 6. Which is equal to 6, right? And for the second scenario, 2 coca candies and 1 milk candy. So for picking 1 milk candy, of course, it's just M times C times C take away 1. And then, of course, the 2 chocolate or the coca candies can swap each other, which means that you need to divide it by 2 factorial, and that's equal to 2. Maybe I'm using another color. Now, for these 2, if they are the same, it means that you can eliminate this and eliminate this, right? To form a fractional equation, such that you can get from this relationship that 6m is equal to 2 times of C take away 2, which means that 3m is equal to C take away 2. All right, so that's the first relationship between the number of milk candies and chocolate candies. But we haven't included the fruit candies yet. So let's move on. For the fruit candies, we know that the total number of ways is going to be F times M times C for all 3 kinds of candies. And that's also the same. So now for these 2, for the last 2 expressions, they are also the same, which means that you can eliminate M and C on both sides to see that 2F is C take away 1. Now we just need to determine which one of them is the smallest. Yeah. So yeah, that's pretty intuitive. M has to be the smallest, right? M has to be the smallest. So let's say M is 1. When M is 1, 3M is 3. C take away 2 is 3, so C is 5. Yes, that's right, bye. We let M be 1. And such that C is 5, right? And then now 2F is C take away 1, which is 4. So F is 2. So altogether, there will be 8 candies at least. 5 adding 1 adding 2, that's 8 at least. All right. So this is kind of an abstract problem. This is pretty much abstract. Technically speaking, I should put C, M, or F all over the total number of candies. But then we know that the denominator has to be the same. right? So we are just counting the numerators. That's the reason why we are just counting the numerators now, okay? So these are not probabilities. These are the number of ways that you can do your selections. Okay, hopefully that's making sense to you. Now I'm just going to count to 3 and see if anyone has any problems. 3, 2, 1. All right. So let's move on to the next one. So this one, I don't think it has got much skills in it, because basically, essentially, I just, do it by intuition, and it's kind of like a trial and errors. But of course, we know that if, why is there an extra line of this condition? Let's cross this out. All right. If they are red and yellow, it's 1 point. If they are red and blue, it's 2 points. If they are yellow and blue, it's 3 points. So we want as many yellow and blues as possible, right? And also, if they are the same color, it's 0 points, which means that I don't want any of them. At least I want some points, right? So I don't want any one of these next to each other. So if I want as many yellow and blues as possible, I'm just going to think about how can I put these three vertices of the same color away from each other. All right. Say, for example, if I am taking this one as yellow, then of course I don't want the top one, the left one, and the right one to be yellow. Yeah. So now we have still 4 options left. We have 4 options left. 1, 2, 3, 4. You can see that 2, 3, 4 are not connected to each other, but 1 is connected to all 3 of them. So it means that I can't put a y at the 1. And I can just put y anywhere else apart from the 1. Yeah. So that's where I can put y. Now, after that, I'm just going to decide on how to put the blue and the red. Yeah. So we know that the red has to be further away from each other if possible. Or maybe not really. But let's see how we can fit the blue in first. All right. You can see that there's a node right there. There's a node right there, which connects to 1, 2, 3 of the remaining vertices. So let's say that is 4, right? And this is 5, okay? So, well, of course, if I put a blue at 5, it is going to connect all the other yellows. But then we need to think about how we can put the remaining 2 blues. So we can't put it at 4. So we have to put it at 2 of the 1, 2, and 3s. But then by doing that, it means that the 4 is left for the red, which means that the other of the 1, 2, 3s is also going to be red. So what I'm saying is that the 5 can't be a blue. Okay? So if the 5 can't be a blue and we don't want the blues to touch each other, then the 4 can't be a blue either. So it means that I have 1, 2, 3 as 3 blues. And now finally 4 and 5 are red. Okay? So now you can see that there are going to be 3 times red blue edges. The other 3 are red yellow edges. And then finally, there are 6 of the yellow blue edges. So what is red and blue? Red and blue is purple. It's 2 points. And red and yellow is 1 point. Yellow and blue is 3 points. So that's 6. That's 3 times 1 equals 3. 6 times 3 equals 18. So altogether, we have 6 adding 3 adding 18. That's 27. Okay. So you need to draw the cube out. You need to draw the cube out and see what's going on there. But like I wouldn't say that there's too many skills there. Just basically intuition. Basically intuition. Because I didn't summarize this question really well. That's kind of like my limit right there. I don't know how to, sort this question really systematically. Like I just know that's gonna happen. Nah, but I mean, by intuition, that's kind of how I solved it. And of course, a little bit of analysis, like what I did just now, but the most of it is like a blur hint of where I should go in my head. Okay, so if we are all fine with this question, we can move on to the next one. So this is a very interesting question, but basically you just need to know what it means, and then it's going to be pretty easy. It's asking them to guess the most likely remainder of ABC divided by 7 based on the numbers they knew. So it means that, well, if they are all guessing 1 as the most likely remainder, how so? For example, if Alice knows A, then what Alice is going to have is just A00, right? In her head, because Alice just knows the hundredths place. And for Bob, it is B0. And for Cindy, it is just C. Well, C is easy because among 1, 2, 3, 4, 5, 6, of course, I know that's just going to be a 1, right? Such that it's going to have a remainder of 1. That's most likely because 1 divided by 7 has a remainder of 1. So within all these numbers that can be formed, of course, it is most likely to have a 1 in there, right? And then for B, for B0, well, if I start with a 10, 10 divided by 7 has remainder 3, right? Yeah, that's right. That's right. And then 20 divided by 7 has remainder 6. 30 divided by 7 has remainder 2. 40 divided by 7 has remainder 5. 50 divided by 7 has remainder 1. So if it is starting with a 1, if it is like the original state of it is already having a remainder of 1, of course, it's going to be most likely to have a remainder of 1, right? Because we know that the numbers go in patterns. Every 7 of them is a pattern. Yeah. So no, it's not a 1. Sorry, it's a 5, 50. So it's going to be 50. And as for A, well, just basically very similar. 100 divided by 7 has remainder 2. 200 divided by 7 has remainder 4. 300 divided by 7 has remainder 6. 400 divided by 7 has remainder 1. So it means that this is 400. So ABC is 451. All right. So this question isn't exceptionally hard, but then we just need to understand what it means. We just need to understand what the question means by that. All right. And now we are moving on to the 2 hardest questions. For question number 13, it is something that we have been talking about in our lesson this week, like the transformation lesson. It's just a pity that, I haven't got this lesson a bit earlier. But yes, I can use the skill of the transformation right there. So, but of course, like on top of that, you still need to know the prior knowledge of, congruent triangles or similar triangles, which you are not required to be fair. So still it is a little bit out of syllabus right there. So you can imagine that if this is 4 and 12, and you want to find the square. Oh, I think that's one condition missing. This should be 45 degrees. This is 45 degrees. Let me see if that's on the paper previously. Just give me 1 second, all right? I'm just going to double check if it's written on the paper. Or is it just that I am missing it? Let me check the paper. One second. All right. Oh, it didn't say that on the paper. That's really nasty. I mean, the Chinese part has it, but the English part doesn't. Probably that's the reason why you didn't solve it. Do you know it is 45 degrees when you're having the test? Do you know BDE is 45 degrees? No? Yes, no? Oh. That's fine. Well, 45 degrees is very amazing because, you know, these two angles, they are all also 45 degrees, right? .45 degrees is the base angle of a right-angled isosceles triangle that has top angle 90 degrees. So if you want to find the area of a square with side BD, the 45 is giving us a very good hint here. Because if you are trying to form a square, you can just try to lengthen this line such that it is a right angle and lengthen DE such that it crosses this point somewhere. All right, so that's going to be, let's say this point is F, okay? So that's going to be like BDF is just a right-angled isosceles triangle, which is half of the square. Okay? And how is that going to help? So the next step is to think about rotating BDA all the way there. It's going to fit in because BD has the same length as BF, right? It's isosceles. AB is also the same as BC because it's isosceles. And also, very importantly, ABD, this angle, is equal to that angle because both of them are right angles. You can see ABC is a right angle, DBF is a right angle. So CBF is equal to ABD in terms of the angles. And these two are congruent triangles. So now what we have is to find DB according to that, right? Or find BF basically. So you can see that this base BC is going to be equal to, what is it? Wait 1 second. Four adding 12 squared divided by 2 and the root of that, which is equal to 8 root 2. So BC is 8 root 2, all right? And that is going to be 4 now. So now again, we need to apply some further knowledge there. So because that is isosceles, so it means that these two angles are going to be the same for vertically opposite angles. right? Let's call them beta. So now what we can say is that triangle BCF is going to be, oh, right, I don't need that actually, because that is going to be a right angle. DCF is also a right angle. Yes, that's right. That's where we have it. Because when I'm rotating BDA to BFC, you can see that the top angle right there, 45 degrees, is going to fill up BCF together with DCB. This is going to be a right angle. If it is a right angle, we can use the Pythagoras theorem for DF. So DF is equal to 12 squared, adding 4 squared, and the root of that, which is equal to 144 adding 16, 160, the root of 160, divided by 2, of course. Oh, no, not divided by 2. What am I doing? The root of 100 is 60. And then in order to find the area of the square, you can see that DF is going to be a diagonal of the square, right? And then for a square, if you know the length of a diagonal, if you multiply the two diagonals, you're going to get the area of this larger square, right? So it means that the diagonal squared is double the area of the square, which means that the area of square with side BD is going to be area of square is equal to root 160 squared divided by 2, which is 80. All right. So it should be 80. And now that's when we are using BC as 8 root 2 and the, like the similar triangle property. So still we need to use the similar triangle property. Well, basically DCE has all the same angles as triangle BCF. Okay, because that is equal to 45 degrees. And we know that if I have 45 degrees and beta, the other angle must be alpha. So it means that that is alpha. And if all three angles of a triangle are the same, it can be considered similar triangles. So you shouldn't have learned about this before, but if you know it, it's going to be very helpful for this question. Because for similar triangles, the ratio between the corresponding sides are always constant. Okay, so now I know that for 12, which is DC, to EC is going to be the same ratio as in triangle BCF, BC to CF, the long side and the short side. So the ratio between the long side and the short side is constant. Now we know that DC is 12. So it means 12 over EC is equal to 8 root 2 over 4. Which if you swap around terms, you can see that EC is equal to 6 over root 2, which is 3 root 2. All right. And it also involves rationalizing it. I can't believe it. But anyways, EC is equal to 3 root 2. In that case, if BC is 8 root 2, EC is 3 root 2, it means that BE is 5 root 2, right? So now the question becomes much simpler. So we know that BE to EC is actually going to be 5 to 3. Which means that the area ratio of BDE to EDC is 5 to 3, just like the equal height model that we have been talking about. And as for the area ratio of ADB and DBC, it is 1 to 3, right? So now we just need to find the area of triangle ABC, which is 8 root 2 squared. So triangle ABC is 8 root 2 squared divided by 2, right? Let's say over 2, which is 64, which means that the area of triangle BCD is equal to 64 times 3/4. That is 48. And for BDE, area of BDE, it is equal to 48 times 5/8, which is 30. So the area is 30 right there. And the first one is 80. All right. So this is really a complicated question. It requires you to know a lot of information on similar triangles and congruent triangles. I didn't think they would have these included. That's way out of syllabus, though. How I calculated BE? Oh, that's because I have 8 root 2. BC is 8 root 2, right? And EC is 3 root 2. So the remaining would be 5 root 2s. 8 take away 3 is 5. So 8 root 2 take away 3 root 2 is 5 root 2. Because if you write that, it's just like a multiplication of 8 and root 2, 3 and root 2, and 5 and root 2, right? So if originally you have 8 of root 2s, you take away 3 of root 2s, you will have 5 of root 2s remaining. Okay, does it make sense? Yeah, hopefully that works for you. All right, so we are at the one last problem. The one last problem is a bit simpler, I would say, but it requires a bit of imagination. If you still remember the last question, dividing the 29 natural numbers from 1 to 29 to n groups. So basically, you don't want any sum to be 30, right? So you can systematically think about the groupings. First of all, I would like to have, for example, I would like to have all the numbers. Let's say from 1 to 29, each number is called, like K1, K2, K3, all the way up to K29, okay? Like these are constants. So let's call them K. So I would like K over 30 to be smaller than 1 and greater than 1/2 for the first group. And why does that range matters? Or it can be greater than or equal to half, since all the constants are different. That's because within this range, it means that using one number is not enough for me to make 30. But using 2 numbers, it will be too big enough for 30, right? So that's why I am putting the range 1.5, 1 and 1/2 alongside the fraction. So we know 1/2 of 30 is 15. So it means that the first set should contain all the numbers from 15, 16, 17, all the way up to 29. Yep. Does it make sense? That is the first set. All right, and for the second set, let's say it is a third, greater than a third and smaller than a half. So that will be 10, 11, 12, 13, 14, right? And the reason why I take that range is because 3 numbers is going to be too big for 30. 2 numbers is going to be too small. So that's what it means by the range. A third to a half. But when do I know when to stop? How do I know when to stop? It's when all the smaller numbers added together is still smaller than 30. Then I can stop, right? So I will just carry on to a range of smaller than a third, greater than a quarter. So we have 8 and 9, because we know a quarter is 7.5. A quarter is 7.5. So we have 8 and 9 there, and 1 to 7 adds up to 28, which means that the remaining set is 1, 2, 3, 4, 5, 6, 7. All right, now. So I have 4 sets, but then we would need to think about, can I fit 8 or 9 anywhere? Such that, well, there will not be 4 sets of these numbers, because we'll try to minimize it, right? So first of all, if I think about putting 8 and 9 into this set, of course it won't fit, because 11 and 12 together. For example, if I put a 9 in there, together with 11 and 12, it's going to make 20. And together with a 10 as well, we are going to make 30, right? So we can't put it in there if 11 and 12 are there. What about the top set? What about the top set? If I'm putting 8 and 9 into the top set, well, then 21 and 22 are going to be in the way to stop me right there, yeah? Because 21 adding 8 is, well, apparently it's going to be, what is it? 21 adding 8 is, no, 21 adding 9 is 30. 22 adding 8 is 30. My brain is just not working. A bit too late of the day. So it means that I can't put 8 and 9 in the top set as well. But of course, I can't put 8 and 9 in the bottom set as well. So, I mean, this is really hard to think of, because at the first try, I didn't figure out the answer is 3. But since I know the answer is 3, I can try to explain how we can think about it. All right. Yeah, that's right. That's right. That's what we are going to do. We are going to move 21 and 22 to the second group. So basically, we're just doing a swap right there. We're just doing a swap right there. So you can first try to think about, say, for example, I insist on putting 8 and 9 in there. All right. I insist on putting 8 and 9 in there. Such that 11 and 12 is now kicked out. Now, I need to squeeze 11 and 12 in there. But then, in turns, 18 and 19 are kicked out. So you can just put 18 and 19 back into this set. Such that this set is now 8, 9, 10, 13, 14, 18, 19. Okay, and the top set is going to be equal to 11, 12, 15, 16, 17, without 18, 19, 20, 21, all the way to 29. All right, so in there still, there should be 3 of these sets without any other, well, without any groups of these numbers added up to 30. All right. And there can be other sets of these. For example, if you just insist on putting 8 and 9 into the top set, then it means that 21 and 22 are kicked out, and you can put 21 and 22 into the middle set. That's also fine. So there's more than one way of doing it. Okay. So is that all right for everyone? All right, then that's basically everything. So the number n is 3. The minimum value of n is 3. And the 3 sets are the first one, the second one, and the third one.